Hi everyone. In the last session, we have started the concept of structures in C. In that, we have defined that a structure is the user-defined data type that can store more than one element of different type, or we can say heterogeneous type. And also, we have differentiated what is an array and structure. An array is the data type which is going to contain more than one element of same type, or we can say homogeneous type. Whereas the structure is going to create a new data type which combines multiple data members of different type, or we can say heterogeneous type. After that, we have seen the syntax of declaring a structure. We have used the keyword struct to declare a structure, and also various methods to create a structured variable. We discussed that whenever the structure or the template or prototype is created, the memory is not allocated. Only the life comes to the structure when we create a structured variable. We have discussed there are two methods for creating a structured variable. After that, the members of the structure can be accessed by using dot operator that we discussed. And also we have seen how to initialize the structure members. That also we have seen. So in continuation of the last session, in today's concept, we are going to discuss some more details like designated initialization of structure members. Let us take a structure struct student, and here I'm taking the members character student name and taking the size as 20, and the next field I'm taking integer rule number, next float marks closing brace, here I'm keeping semicolon. We discussed that a structure ends with semicolon. After that, we are writing the main integer main, and inside the main I'm creating the variables, structured variables. So whenever you declare structured variable within the main, again you have to mention struct, the name of the structure is student, and you initialize the variable here s1. Now while declaring the structured variable s1, here you can initialize the values in the order we have mentioned in the struct student. Means within the opening brace and closing brace, we are going to enter first the student name, next to roll number, marks that we have seen in the last session. But here we are going to use the different method that is called the designated initialization. What do you mean by the designated initialization? Here you can give the values of the structure members in any order, not in the sequence. When you give the values, when you initialize the values in the sequence, no need of mentioning the order, right? So here you can mention the values of structure members in any order by specifying the dot operator. For example, here I'm writing dot rule number, means second element I'm taking first. Any element you can take first. No need of following the order. Just you mention dot rule number equals to 100. The next dot s name equals to, what do you say, some name like Anil, like double quotes close, comma, dot marks equals to 205.6. So like that, we can give the elements in any order by specifying the dot operator that is known as designated initialization. Now we will see an array of structures. What do you mean by an array of structures? Let us define a structure struct student opening brace, and you take the name student name and you give the size dimension 10 and integer rule number. Next, this last one is float marks closing brace, and before this I'm writing like this s is the structured variable. Here I'm giving the dimension 5, s of 5, means we are using the concept of array, which is nothing but array of structures. S of 5. What do you mean by S of 5? S of 5 in the sense we have five five locations, right? First one is S of 0 and second one is S of 1, S of 2, this is S of 2, and S of 3, and this is S of 4. Now S of 0 again divided into 3 fields. S of 1 also again divided into 3 fields, and so on. What S of 0 is going to contain? S of 0 is a structured variable which is going to contain 3 fields. The first field we are talking about is student name, and second one is roll number, and third one is marks. Similarly, the structured variable S of 1 also going to contain 3 fields. The first one is student name, and next second one roll number, and third one is marks. Similarly, we have S of 2, S of 3, S of 4. Each one is going to contain 3 fields. Now, how to access the student name for S of 0? That can be accessed by S of 0 dot S name. And second one is S of 0 dot roll number. And next S of 0 dot marks. This is the way of accessing the members for the structured variable S of 0. S of 5 in the sense there are 5 students. In that sense, we have used S of 5. So instead of taking the structured variable S1 comma S2, we can also use S1 comma S2 comma S3 comma S4 comma S5. Instead of saying 5 structured variables, I'm going to create an array of structures of 5 locations, and each location again further divided into 3 locations. Now, student name is going to contain 10 bytes, roll number 4 bytes, marks 4 bytes, 18 bytes without padding. Just understand this, without padding. So when you take padding, it is going to take, so by default, it will come with padding. The answer we get, the amount of memory allocated for the structured variable S of 0 is 20. Now the second variable S of 1, the members of the second variable S of 1, it can be accessed by S1 dot S name, next S1 dot roll number, S2 dot roll number. So this is the way of accessing the members by using array of structures. So for S of 0, 20 bytes, for S of 1, 20 bytes, total 5 into 20, total how much memory is allocated? 100 bytes. S0 20 bytes, S1 20 bytes, S3 20 bytes, S2 20 bytes, S4 20 bytes. So 5 into 20, the amount of memory allocated for all these structured variables becomes 100. This is a way of using an array of structures. After array of structures, next we can use the concept of pointer to a structure. What do you mean by pointer to a structure? So let us define a structure, struct, and the name of the structure here we are using book, and again we are using the same fields, character, book name, and here the size or the dimension I'm taking 10, and integer, pages, and float, you take the field name marks. Here I'm closing this structure. Structure ends with semicolon. After that, inside the main block, I'm going to create a structured variable, struct. The name of the structure is book. I'm taking B1. And next, I'm creating another structure pointer variable. This is star PTR, right? So this is the pointed of type book, which is nothing but the structure. This is the pointer to a structure. Now in the pointer PTR, we are going to store the address of B1, right? By using the pointer, we are going to access the members of B name, pages, marks. How to access the members of structure by using pointer PTR? We can use this notation PTR of arrow operator or pointer to member operator name. Just I'm writing the rough code. So while executing the Visual Studio programs, we will see PTR of name. The name member can be accessed like this, PTR of name, and second one is PTR of pages, book name. This is book name, PTR of pages. Next PTR of price. This is a way of accessing. Here I'm not using the dot operator. If you use an ordinary structured variable, we can access the members by using dot operator. But here we are storing the address of the structured variable B1 in the pointer, and by using the pointer, we are accessing the members by using arrow, means pointer to member operator. See here, what do you mean by this PTR of B name? Please remember, PTR of B name is same as equivalent to star of ptr of dot name, book name. These are same, equivalent. Now, see, whenever we create a structured variable b1, then by default the b1 is going to store the base address. See, here I'm going to take the memory representation of the structured variable. The name of the structured variable is book here. The book consists of how many? Book name, pages. So this is book name and pages. Assume that the first field name is book name and second one is pages. And next, last one is marks. And every location is having its own address. The base address of the first location, book name. Book name is again divided to how many bytes? 10 bytes, right? 10 bytes. We are taking the first address, assume that 100 is the base address, right? Now, the base address 100, the base address of the first location address is 100. Now, pages it is also going to contain, assume that if the first base address is 100, next second location 101, 102. So, we have 110. Okay, after 110, now we are taking pages. Pages are going to take how many bytes? 4 bytes. So first here after 110 we are taking 111. Okay, after 111 we are going for the next location as 115. Why? Because pages are going to take 1 byte. See, the entire address of this structure is stored in the structured variable b1. Now b1 itself represents the base address 100. The whole structure address is 100 and the address of the first location is also 100. Now, by referring the b1 or 100, we can access the first member. How? By saying b1 dot b name. Okay, b1 is nothing but 100. Okay, by using this address, we are referring to the first location name, second location book name, second location pages, next location price. Now, the whole structure address we are storing in PTR. Okay, now PTR contains the structure address. Now, star of PTR, actually star of 100. Star of 100, again we are getting 100. 100 dot bname, we are getting the same name. Okay, so PTR stores the address of b1. So by using this PTR, we are referring to the field names by using arrow operator. This is a way of accessing the members by using a pointer variable PTR, right? This is about using a pointer to a structure. Now we will see how the memory is allocated to the structure members in more details. See, you take a structure, struct, and the name of the structure is book, and the first field name you take is character book name, and the dimension here is 10, and next field name is integer, represents the number of pages, and the last one is float. Here you take the field name is price, and the structured variable here we are taking is b1. Now we will see how much memory is allocated for the structured variable b1 in more detail. Now you do one thing, you draw a memory representation for this. I'm taking the memory representation here. Book name requires 10, right? You take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pages requires 4 bytes, right? 1, 2, 3, 4. And price also requires 1, 2, 3, 4. Okay, just I'm assuming it last one is one byte. Okay, now we will change the memory representation accordingly. Now, before moving on to how much memory is allocated for the structured variable b1, let us take 32-bit processor. We may have 32-bit processor, or we can have 64-bit processor. What do you mean by a 32-bit processor? A 32-bit processor can read at a time 32 bits of information. A 64-bit processor can read 64 bits of information from the memory, or it can access at a time 64 bit of information. and here it can process or it can access 32-bit of information. See, for 32-bit processor, 32 bits means 4 bytes. 4 bytes you consider it as one word. That means a 32-bit processor at a time reads one word of memory. It's not going to read 1 byte of memory. It is going to read one word of memory. That means it is going to read 4 bytes of memory at a time. That is about the 32-bit processor, right? Now, we are going to use the concept of CPU cycles. What do you mean by a CPU cycle? The amount of memory it read means 4 bytes of information or one word is called one CPU cycle, right? Now, in the first CPU cycle, it is going to read at a time one word means 1, 2, 3, 4. This is we are designating as the first cycle, first CPU cycle, right? Next, in the second cycle, again 1, 2, 3, 4. So here we have completed. This is the second cycle. Now, in the third cycle, again it is going to read 1, 2, 3, 4. This is about the third cycle, right? The amount of memory required for the book name is 10 bytes. 1, 2, 1, 2, and this is 3, 4, 5, 6, 7, 8, 9, 10. 10 bytes of memory is required for the book name. But it also read 2 empty bytes here. 2 empty bytes. These 2 empty bytes are not required for the book name. What is the next field here? Pages. Pages requires how much memory? Pages requires 4 bytes, right? So, but how much memory is available here? Only 2 bytes. To have 2 more bytes, it has to go for the second cycle. That means from the second cycle, it is going, next cycle, it is going to take these 2 bytes. These 2 bytes and these 2 bytes. So next 2 bytes can be read only in the second cycle. That means to have these 4 bytes of memory for the pages, it needs 2 CPU cycles. Okay. So to refer the field name pages, it requires 2 CPU cycles. So instead of wasting the CPU cycles, what we are going to do internally, what internally happens is this is treated as empty. These 2 bytes left as empty. Now in the second cycle, what happened? It is going to read continuously 4 bytes. This is the second, assume that fourth cycle. See, in the fourth cycle, 4 bytes of memory is read at a time for the field name pages. What about the 2 bytes which are left in the third cycle? Those kept as empty. Okay. So 4 bytes are read in the fourth cycle for pages. This is for pages, and all these are for book name. Now, what about price? Again, it requires 4 bytes. Okay. Pages, 4 bytes. Next, price, 4 bytes. So for price, what happened? Again, in the next cycle, fifth cycle. This is about the fifth cycle. 1, 2, 3, and 4. Okay. Now, these are 2 empty. 1, 2, 3, 4. These are the 4 bytes, one word in fourth cycle required for pages. 1, 2, 3, 4. These are the 4 bytes which are required for the price. Now, tell me how much memory is allocated now. See, 1 to 10, 10 bytes plus empty, how many bytes? 2 bytes plus. We are considering this empty slots also. Pages requires how many bytes? 4 bytes. And price requires how many bytes? 4 bytes. Total 20 bytes of memory is allocated. 20 bytes of memory is allocated for the variable b1. But generally, we thought that b1 is going to take 10 bytes, 4 bytes, 4 bytes. Total how many bytes? 18 bytes. So this is the wrong assumption. Means 18 bytes of memory allocated is the wrong assumption. Actual, when you print the size of the variable b1, you are going to get the 20 bytes of memory. How? Why? Because 20 empty bytes are padded. 20 empty bytes are padded. That we call it as structure padding. What do you mean by structure padding? Extra empty bytes which are added, okay, for CPU cycles, that is known as structure padding. So this is how memory is allocated for the structured variable B1. The correct answer is 20 bytes. Now you can ask one important thing, how to get only exactly 18 bytes? We don't want any these empty bytes which are padded. To get the exact, so when we add empty bytes, it means that the memory is wasted. We are trying to minimize the cycles, but the memory is wasted. Okay, exact amount of memory is not allocated. So to get the exact amount of memory, we use the concept of structure packing. What is that? Structure packing. We use the concept of structure packing. That means we use the word pragma, pragma, and we are writing pack 1. 1 means on, 0 means off. We are switching on the packing. When you say pragma pack 1, and after that if you say struct book opening brace and character book name and 10, and if you take integer pages and float price, and if you declare the variable b1, then how much memory is allocated for b1? In this case, for b1, 10 bytes plus 4 bytes plus 4 bytes. Total how many bytes? 18 bytes. So 4 I'm taking for integer, 4 I'm taking for float, and this is for the book name, 10 characters. So here we are getting 18. Whenever you use pragma pack 1, when we use structure packing, then padding is eliminated and we are getting the answer 18. Until unless you use pragma pack 1, you can't say that the amount of memory B1 is 18. Only B1 becomes 20. This is about structure padding and structure packing. With this, I'm going to close the session. Next, we will see more details. Thank you for watching.